Welcome to this comprehensive module on CI/CD pipeline secrets management. Secrets management is one of the most critical aspects of modern DevOps practices. Throughout this module, we'll explore how to properly handle sensitive information in your CI/CD pipelines. This knowledge is essential for any DevOps professional, as improper secrets management is one of the leading causes of security breaches in modern applications. Why is this topic so important? Think about all the passwords, API keys, tokens, and certificates that your applications need to function. Each of these secrets represents a potential vulnerability if not managed correctly. By the end of this module, you'll understand not just the theory behind secrets management, but also practical hands-on approaches to implementing it in your CI/CD pipelines. Let's begin this journey into securing your pipelines and protecting your organization's most sensitive information. Let's start with a fundamental understanding of secrets management in the context of CI/CD pipelines. Secrets management refers to the secure storage, access, and management of sensitive information used in software applications and infrastructure. This includes passwords, API keys, database credentials, encryption keys, and any other confidential information that your applications need to function. Secrets management is more than just storing sensitive data. It's about creating a comprehensive system that handles the entire lifecycle of these secrets. Think about a typical enterprise application. It might need to connect to multiple databases, authenticate with various third-party services, and maintain different sets of credentials for development, staging, and production environments. Each of these connections requires secrets, and each secret needs to be generated securely, stored safely, distributed to the right services, rotated regularly, revoked when necessary, monitored for unauthorized access. This is what we mean by secrets management. It's a complete ecosystem for handling sensitive information throughout your application's lifecycle. Understanding this holistic view is crucial as we dive deeper into specific implementation strategies and best practices. When implemented correctly, secrets management becomes an invisible but crucial part of your infrastructure, ensuring that your applications can securely access the resources they need while maintaining the highest levels of security. The significance of secrets management in CI/CD pipelines cannot be overstated. Let's examine each key aspect in detail. First, let's talk about protecting sensitive information. In today's interconnected systems, a single compromised secret can lead to catastrophic consequences. Leaked API key may lead to unauthorized access to production databases, resulting in significant data breaches. Proper secrets management ensures that your sensitive data remains secure and accessible only to authorized individuals and systems. Regarding compliance and regulatory requirements, many industries have strict standards that must be met. For instance, if you're working in healthcare, HIPAA compliance requires specific handling of sensitive data. Financial services must comply with regulations like PCI DSS, which has explicit requirements for encryption key management. Your secrets management strategy must align with these regulatory frameworks. Scalability and automation are crucial in modern DevOps practices. As your organization grows, managing secrets manually becomes increasingly complex and error-prone. Imagine having to manually update database credentials across hundreds of microservices. It's simply not feasible. This is where automated secrets management solutions become invaluable, allowing you to manage secrets at scale while maintaining security. Finally, collaboration and team management aspects are often overlooked but vitally important. In a typical organization, different teams need different levels of access to secrets. Developers might need access to development environment credentials, while operations teams need production access. A robust secrets management system provides the necessary controls and audit capabilities to manage these access levels effectively. These aspects work together to create a comprehensive security posture for your organization. As we progress through this module, we'll explore practical implementations that address each of these significant areas. Let's dive into environment variables, a fundamental concept in secrets management. Environment variables are named values that provide information to Unix-based operating systems and applications, but their role in secrets management deserves special attention. When working with environment variables in a DevOps context, it's crucial to understand their scope and behavior. These variables are accessible system-wide, which means any process running on the system can potentially access them. This characteristic makes them both powerful and potentially dangerous when used for secrets management. Let me share a practical example. Suppose you're deploying a Node.js application that needs to connect to a database. You might be tempted to store the database password in an environment variable like this. Database_password equals my secret password. While this is better than hard-coding the password in your code, there are several considerations to keep in mind. 1. Environment variables persist in the system until explicitly unset or the system is restarted. 2. They can be viewed by anyone with access to the process environment. 3. They might appear in log files or error messages if not handled carefully. This is why we need to combine environment variables with other security measures and proper secrets management tools, which we'll discuss in later slides. The key is understanding when and how to use environment variables appropriately in your CI/CD pipeline while maintaining security. Let's explore the practical aspects of working with environment variables in Bash, a skill that's essential for DevOps professionals. Setting environment variables in Bash is straightforward, but there are important nuances to understand. The syntax variable_name equals value is used to set a variable, but notice there are no spaces around the equals sign. This is crucial. A common mistake developers make is adding spaces, which results in Bash interpreting it as a command rather than a variable assignment. When accessing environment variables, you have two options: $variable_name or $variable_name. The curly brace notation, $variable_name, is preferred in scripts as it clearly delineates the variable name from surrounding text. For example, echo welcome $user versus echo welcome $user. The export command is particularly important in CI/CD contexts. Without export, variables are only available in the current shell session. This means if your pipeline runs multiple scripts or processes, they won't have access to these variables unless they're exported. Here's a practical example of how this might work in a CI/CD pipeline. Export db_host equals productiondb.example.com. Export db_port equals 5432. Export db_name equals myapp. Hash. This script will have access to the variables /deploy database migrations.sh. Remember, while environment variables are useful for configuration, they should be used carefully with secrets. In upcoming slides, we'll discuss more secure alternatives for handling sensitive information. Understanding commonly used environment variables in Unix systems is crucial for DevOps professionals. These variables form the foundation of system configuration and are often integrated into CI/CD pipelines. Let's examine each important variable and its significance in DevOps workflows. The path variable is perhaps the most frequently used. It determines where your system looks for executable files. In CI/CD pipelines, you might need to modify path to include custom tool directories or specific versions of utilities. For example, when working with multiple versions of Node.js or Python, you'll often need to adjust path to use the correct version. The home variable points to the user's home directory. This is particularly important in CI/CD contexts because build processes often need to access configuration files in the home directory, such as set/config for deployment keys or npmrc for private NPM registry credentials. The user variable stores the current username, which is crucial for audit trails and access control in your pipelines. When running automated processes, it's important to know which user context they're executing in. The shell variable indicates the current user's default shell. This becomes relevant when your pipeline scripts need to execute specific shell commands or handle shell-specific syntax. The pwd variable stores the current working directory. In CI/CD pipelines, knowing and validating the working directory is crucial for ensuring scripts operate on the correct files and directories. Pro tip: when you run the env command to see all environment variables, pay attention to any sensitive information that might be exposed. This is particularly important when debugging pipeline issues, as you don't want to accidentally log sensitive variables. Let's explore the intersection of Unix environment variables and secrets management, a critical area where security meets practicality in DevOps. When it comes to storing secrets, the first rule is to avoid hard-coding sensitive information directly in scripts or configuration files. Numerous security incidents may occur when credentials are accidentally committed to source control because they are hard-coded in configuration files. Instead, use environment variables as a more secure alternative. However, environment variables alone aren't enough. Modern secrets management requires sophisticated tools like HashiCorp Vault, AWS, Secrets Manager, or Azure Key Vault. These tools provide crucial features that simple environment variables don't. Encryption at rest and in transit. Access control and audit logging. Automatic secret rotation. Integration with identity management systems. Version control for secrets. Let's look at a practical example of how this might work in a pipeline. Store sensitive data in a secrets management tool. 2. During pipeline execution, retrieve secrets and set them as environment variables. 3. Use these variables in your application, but only for the duration of the pipeline run. Here's a sample approach using AWS Secrets Manager. Retrieve secret and set as environment variable export db_password equals $AWS Secrets Manager get secret value minus secret id_prod/db/password -query secret string -output text use the secret in your application /deploy application.sh. Cleanup, important, unset db_password. Remember to follow the principle of least privilege. Only grant access to secrets that are absolutely necessary for each part of your pipeline. Understanding how to safely access secrets stored in environment variables is crucial for maintaining security in your CI/CD pipelines. When accessing secrets, always use secure methods that won't inadvertently expose the values. For example, when debugging, avoid using $secret_name directly, as this might log the secret value. Instead, confirm the existence of the secret without displaying its value. If $$db_password, then echo database password is set. Else echo error database password is not set. 5. Let's examine some common types of secrets you'll encounter in DevOps. DB_password. Database credentials are among the most sensitive secrets. They should be rotated regularly and never shared across environments. API_key. External service authentication. Keys need careful management. Each service should have its own key, and keys should be environment-specific. Access_token. Authentication tokens, especially for etcd systems, should have limited scope and duration. SSH_key. Private SSH keys for deployment need extra protection. Consider using separate keys for different environments and rotating them regularly. Remember, even when using environment variables, secrets can be exposed through Process Listing Tools, PSO, core dumps, error logs, shell history. Always implement additional safeguards and follow security best practices when handling these sensitive values. Let's dive into the first set of crucial best practices for secrets management in CI/CD pipelines. Centralized secret storage is fundamental to maintaining security and control. Think of it as having a single source of truth for all your sensitive information. Instead of having secrets scattered across different configuration files, repositories, or servers, centralize them in a secure vault. For example, if you're using HashiCorp Vault, you might structure your secrets like shown here. This hierarchical structure makes it easier to manage access control and audit usage. Regarding encryption and access controls, implement multiple layers of security. 1. Encrypt secrets at rest using strong encryption algorithms. 2. Ensure encryption in transit using TLS. 3. Implement role-based access control, RBAC. 4. Use the principle of least privilege. 5. Enable multi-factor authentication for accessing secrets. A practical example of implementing RBAC Lite might look like: Development Team. Read access to development secrets only. Operations Team. Read access to all environments. Security Team. Audit access to all environments. CI/CD pipelines. Read-only access to specific secrets needed for deployment. Let's continue with our second set of best practices for secrets management in CI/CD pipelines. Secure secret distribution is critical in maintaining the integrity of your system. When implementing secret distribution, consider using dynamic secrets, credentials that are generated on demand and have a limited lifetime. For example, instead of using a static database password, generate temporary credentials for each pipeline run. Secret rotation is another crucial practice. Implement automated rotation schedules based on time-based rotation, for example, every 30 days. Usage-based rotation, for example, after 1,000 uses. Event-based rotation, for example, after team member departure. For audit and monitoring, ensure you're tracking who accessed what secrets and when, failed access attempts, secret rotation events, configuration changes. Set up alerts for suspicious activities such as multiple failed access attempts, access from unusual IP addresses, off-hours, access attempts, sudden increase in secret access frequency. Let's explore two powerful secrets management solutions that are widely used in the industry: HashiCorp Vault and AWS Secrets Manager. HashiCorp Vault has become the de facto standard for secrets management in many organizations. Its key strengths include open source nature, allowing full customization, support for dynamic secrets, built-in encryption as a service, extensive API and CLI tools, high availability configuration options. Here's a practical example of using Vault in a CI/CD pipeline. AWS Secrets Manager, on the other hand, excels in AWS integrated environments. Native integration with AWS services, automatic secret rotation for supported services. Let's explore two additional powerful secrets management solutions: Azure Key Vault and GitLab Secrets Management. Azure Key Vault is Microsoft's robust solution for secrets management, particularly well-suited for organizations heavily invested in the Azure ecosystem. It provides centralized secret management with strong encryption, integrated access policies with Azure Active Directory, automated certificate management, hardware security module, HSM backup. Here's how you might integrate Azure Key Vault in a pipeline. GitLab's built-in secrets management is particularly valuable for teams already using GitLab for their CI/CD needs. It offers direct integration with GitLab CI/CD pipelines, group-level and project-level variables, protected variables for sensitive information, masked variables to prevent accidental exposure in logs. A typical GitLab SciCD configuration using secrets might look like this. When choosing between these solutions, consider 1. Your existing infrastructure and tooling. 2. Compliance requirements. 3. Team expertise. 4. Scaling needs. 5. Budget constraints. Remember, the best solution is often the one that integrates smoothly with your existing workflow while meeting your security requirements. Let's examine a practical GitHub Actions workflow that demonstrates how to properly handle secrets in a CI/CD pipeline. This example showcases real-world implementation of the concepts we've discussed. The workflow begins with the standard GitHub Actions trigger configuration running on pushes to the main branch. Notice how we're using the env section to declare our environment variables. This is a crucial part of secrets management in GitHub Actions. The syntax $secrets.secret_name is GitHub's secure method for accessing secrets stored in your repository settings. These secrets are encrypted at rest using a libsodium sealed box, never exposed in logs, only decrypted when needed during workflow execution, automatically masked if accidentally printed to logs. Let's break down the workflow structure. 1. The workflow runs on Ubuntu, latest for consistency and security. Environment variables are scoped to the job level. 3. The secrets are accessed using GitHub's secure syntax. 4. The build process uses these secrets safely. One important detail to note: while we're echoing the secrets in this example for demonstration, in a real production environment, you should never output sensitive values, even in secured logs. Instead, pass them directly to your applications or services that need them. Let's delve into the details of our example pipeline and understand each component's role in secure secrets management. The pipeline runs on every push to the main branch, which is a common trigger point for production deployments. This automation needs to be balanced with security. You want automated deployments, but you also need to ensure secrets are handled safely throughout the process. The build and deploy job demonstrates several key security practices. Running on Ubuntu, latest ensures we're using a clean, updated environment. 2. Environment variables are scoped to the job level, minimizing exposure. 3. Secrets are retrieved using GitHub's secure mechanism. The pipeline steps follow a logical progression: code checkout, Node.js setup, dependency installation, build process, deployment. Each step has access to the secrets it needs, but only within its specific context. This implementation of the principle of least privilege helps maintain security throughout the pipeline execution. Remember, while this example uses Node.js, the same principles apply regardless of your technology stack. The key is understanding how to securely pass and use secrets within your specific build and deployment process. Let's discuss how to properly implement and use this pipeline in your own projects. The setup process requires careful attention to security details. First, adding secrets to your GitHub repository requires administrative access. Navigate to your repository settings tab, then to secrets and variables, and finally to actions. Here, you can add your DB_password and API_key securely. Some important considerations when adding secrets. Use strong, unique values for each secret. 2. Never reuse secrets across different environments. 3. Consider using temporary or rotated credentials where possible. 4. Document the purpose and scope of each secret. The github/workflows/main.waml file should be committed to your repository's main branch. However, be careful not to commit any actual secret values. These should only be configured through GitHub's secrets interface. A best practice for testing your pipeline is to 1. Set up a development environment with non-production secrets. Test the pipeline configuration with safe values. 3. Verify that secrets are properly masked in logs. 4. Gradually promote to staging and production environments. Remember to regularly audit your secrets and remove any that are no longer needed. Unused secrets represent unnecessary security risks. Now let's talk about your hands-on assignment, where you'll apply everything we've learned about secrets management in a practical context, using GitLab CI/CD. This assignment is designed to give you real-world experience in implementing secure secrets management practices. You'll be working with GitLab's built-in secrets management capabilities, which is a valuable skill in many DevOps roles. The skills you'll develop through this assignment are directly applicable to real-world scenarios. Many organizations use GitLab for their CI/CD needs, and understanding how to properly manage secrets in GitLab pipelines is a crucial skill for any DevOps professional. Think of this assignment as an opportunity to build something you can actually use in your portfolio. The principles you'll apply here are the same ones used in enterprise-level pipeline security implementations. Let's examine the objectives of this assignment in detail. This hands-on exercise will enhance your existing CI/CD pipeline by incorporating robust secrets management. The main objective is to take your existing GitLab CI/CD pipeline and enhance it with proper secrets management. This isn't just about storing secrets, it's about implementing a comprehensive secrets management strategy that follows industry best practices. You'll need your GitLab account from the previous assignment. If you haven't completed the previous assignment, now would be a good time to catch up. The skills build upon each other, and understanding basic pipeline configuration is crucial for implementing secure secrets management. The sample application you'll be working with provides a perfect playground for implementing various types of secrets management. You might be handling database credentials, API keys, or deployment tokens, all common scenarios in real-world applications. This assignment will give you practical experience with identifying sensitive information in applications. 2. Implementing secure storage solutions. 3. Managing access controls. 4. Monitoring and auditing secret usage. 5. Implementing secret rotation strategies. These skills are directly transferable to your professional work, whether you're in a startup or an enterprise environment. Let's examine the first set of tasks for your assignment in detail. These initial tasks lay the groundwork for implementing secure secrets management in your pipeline. The first task is to identify sensitive information in your application. This is a crucial skill in secrets management. You need to know what to protect before you can protect it. Look for database credentials, API keys, authentication tokens, encryption keys, service account credentials, configuration data that should be environment-specific. When configuring GitLab CI/CD secrets, you'll be working with GitLab's built-in features. Navigate to settings greater than CI/CD, greater than variables in your GitLab project. Here, you'll need to 1. Add your identified secrets as protected variables. 2. Use meaningful naming conventions. 3. Consider the scope of each secret. 4. Determine which secrets should be masked in logs. Document your secret management strategy. Remember, the goal isn't just to store secrets, but to implement a secure and maintainable secrets management system that could scale with your application. Let's dive into the second set of tasks, focusing on implementing secrets in your pipeline configuration. Updating your GitLab CI.yml file is a critical task that requires careful attention to detail. You'll need to 1. Replace hard-coded values with references to CI/CD variables. 2. Ensure secrets are only accessible in stages that need them. 3. Implement proper error handling for missing secrets. 4. Add validation steps to verify secret availability. Here's what a secure pipeline configuration might look like. Testing your updated pipeline is crucial. You should 1. Verify that secrets are properly masked in logs. 2. Confirm that protected branches have access to protected variables. 3. Test error handling for missing or invalid secrets. 4. Validate that secrets are only accessible where needed. Let's explore the final set of tasks, focusing on documentation and best practices implementation. Documentation is crucial for maintaining a secure secrets management system. Your documentation should include 1. A comprehensive inventory of all secrets used in the pipeline. 2. Access control policies and procedures. 3. Secret rotation schedules and procedures. 4. Emergency procedures for compromised secrets. 5. Audit and monitoring configurations. When documenting best practices, consider how secrets are generated and stored, who has access to what secrets, when and how secrets are rotated, how secret access is monitored and audited, what security controls are in place. Remember to include examples and clear instructions for common tasks like adding new secrets, rotating existing secrets, handling secret compromises, auditing secret usage, troubleshooting common issues. This documentation will be invaluable for team members and future maintainers of the system. Let's discuss the deliverables for this assignment in detail. Your presentation should comprehensively demonstrate your implementation of secure secrets management. Your updated GitLab repository should show 1. A well-structured GitLab key.wami file that properly handles secrets. 2. Clear documentation of your secrets management approach. 3. Implementation of security best practices. 4. Proper error handling and validation. When presenting your challenges and solutions, consider initial setup difficulties and how you overcame them. Security considerations that influenced your decisions. Trade-offs between security and usability. Lessons learned during implementation. Regarding workplace implementation, discuss how this could be scaled for larger teams. Integration with existing security policies. Potential cost implications. Training requirements for team members. For potential enhancements, consider automated secret rotation, enhanced monitoring and alerting, integration with external secret management tools, additional security controls. Your pipeline documentation should be comprehensive yet accessible, serving as a reference for future team members. We've reached the end of our module on CI/CD pipeline secrets management. This is your opportunity to clarify any concepts we've covered or explore additional aspects of secrets management that interest you. Consider asking questions about specific implementation challenges you're facing, best practices for your particular use case, integration with other security tools and practices, real-world scenarios and their solutions. Remember, there are no trivial questions when it comes to security. Every question helps build a better understanding of how to protect your organization's sensitive information. Thank you for your attention throughout this module. Your commitment to understanding and implementing proper secrets management will contribute significantly to your organization's security posture.